Hello students. In last video, the definition of increasing and decreasing functions in algebraic methods, analytical methods, and also using the calculus way. How to easily prove that the function is increasing or decreasing, it is increasing or decreasing at a particular point, or monotonically increasing and monotonically decreasing. Here solving some examples. You know that the given functions y is equal to f of x defined in the intervals, closed intervals a to b, in closed intervals a to b, and it is continuous functions and it is differentiable in open intervals a to b. If dy upon dx is means f dash x, this value is positive for each x belongs to the intervals, you said that it is increasing functions. This value is negative, then you said that this value is decreasing functions. At the point x is equal to, at a particular point or in for each x belongs to the interval, this value is 0, it is a constant functions, neither increasing nor decreasing. At a particular point is also at the point x equal to a, you can say that, or x equal to c, this value is positive increasing, negative decreasing, and equal to 0, you say that either neither increasing nor decreasing, or it is either increasing or decreasing this also. It's clear? Already you know this result. Here solving, show that the function f of x is equal to 7x minus 3 is strictly increasing functions. So that this function is strictly increasing functions. Is clear? Example. Solution. Here the given function f of x is equal to 7x minus 3. This function is a polynomial function. Therefore, domain is set of all real numbers. It's clear? You know that which is in the form of y is equal to ax plus b forms. This one is a straight line. Here y is equal to mx plus c forms. Generally you say that it is a straight line. Y is equal to mx plus c. M is slope of the given line. Here m is positive, the angle is always acute angle. M is negative, the angle is obtuse angles. Is clear? Y is equal to 7x plus 3 means, suppose in geometrically you can say that it is a straight line. Is clear? Put x equal to 0, y intercept is 3, therefore the line is like this. It's clear? This intersect the y-axis. It means this one is a straight line with the slope is equal to, here you know that the slope is positive because 7 is positive, is acute angle, it is belongs to the interval 0 to 90, therefore curve. Here x1 is increases, y is also increases. This one is y-axis, x increases, y is also increases, therefore this line is increasing, monotonically increasing. Generally you can say that. That one is, you can say that in calculus method using the derivative, prove that very simple, this function is always increasing functions, or you said that this function is monotonically increasing, or this function is strictly increasing functions. Again, just differentiating with respect to x. Therefore, what is the value of f dash x? This value is 7 into x. 7 constant, derivative of x is 1. 1 into 7 means 7. Minus derivative of 3, 0. 7 minus 0 means 7. You know that this value is not important. Here you said that this value is positive or negative. This value is positive for each x belongs to the set of real numbers. You can take any real number, this value is positive. For each x belongs to the domain of the given functions. This one is the domain of the given function. It's clear? ಯಾವುದೇ ಪಾಯಿಂಟ್ ತಗೊಂಡ್ರು ಇದು ಯಾವಾಗಲೂ ಪಾಸಿಟಿವ್ ಎಫ್ ಡ್ಯಾಶ್ ಎಕ್ಸ್ ಆರ್ dy upon dx is positive for each x belongs to the given domain. Therefore, you can say that f of x is strictly increasing functions. This one is strictly increasing functions. Very simple. Just verify in a given domain this function is positive or this function is negative. Or suppose show that the functions f of x is equal to e raised to 2x. Yeah, is strictly increasing functions. Increasing function. These are very simple, isn't it? You know that the exponential function is always increasing functions. Here x is positive. The index value is positive. It is always increasing functions. When x increases, y is also increases. The graph of this function is exactly equal to like this. All the exponential functions is passing through the point 0, 1. Here x increases, y is also increases. This one is monotonically increasing functions. Here what is the domain of the given functions? The domain is set of all real numbers. We could draw the graph. You write using calculus methods. Here the given functions y is equal to f of x. Its value is equal to 2x. Simply say that y is equal to f of x. F of x means 2x. Just differentiating y with respect to x. You know that derivative of e raised to with respect to 2x. Into derivative of 2x with respect to x is 2. Here 2 into e raised to 2x. It's clear? Here 2 is positive. The exponential function value is always positive. The range is equal to the set of non-negative real numbers. Positive real numbers. 0 is not belongs to that side. It is positive real number. Therefore, this value is always positive for each x belongs to the set of real numbers or domain of the given functions. Therefore, f of x means e raised to x is strictly increasing functions. Strictly increasing functions. This function is strictly increasing functions. It's clear? Its domain is always set of real numbers. Suppose here find, show that the functions f of x is equal to, this case, e raised to minus 3x or e raised to minus x. Verify is strictly decreasing function. Decreasing function. Here also the given function is f of x is equal to e to the power minus x. You know the graph of this function is always like this forms. Not intersect the x-axis like this. The domain is always the set of. This one is x increases, y is decreases. Here without draw the graph, directly using the derivative. Here differentiating with respect to x, f dash x equal to e raised to minus x, the derivative of e to the power with respect to minus x into derivative of minus x. Minus 1 is constant, derivative of x is 1. It means minus 1 into, it means minus e raised to minus x. Or you can write minus 1 divided by e raised to x. E to the power x is always positive. Positive into negative, this value is always less than 0. For each x belongs to the domain of the given functions. Is clear? Each x belongs to the domain of given functions. Here the domain is equal to the set of real numbers. Remember, therefore this functions f of x is strictly decreasing function. This one is strictly decreasing functions. Is clear? Show that the functions f of x is equal to, I already explained in last periods. Suppose here the sin x or cos x is strictly increasing in the intervals 0 to pi by 2. Second one, increasing functions in the intervals, right here, increasing in the intervals 0 to pi by 2, decreasing in the intervals pi by 2 to pi, neither increasing nor decreasing in the intervals 0 to pi. Separate questions actually. Here also the solutions. The method is same. Here the given functions f of x is equal to sin x. Just differentiating with respect to x, then we get f dash x equal to derivative of f of x with respect to x is cos x. Is clear? In each case, separately find the derivative of the function's values in a given intervals. Here you know that the first one is for each x belongs to the intervals 0 to 5 by 2. Here you know that cos x is always positive, that is f dash x is positive, therefore f of x is increasing. F of x is increasing functions in the intervals 0 to pi by 2. It's clear? And second case, for each x belongs to the intervals pi by 2 to pi, cos x lies in second quadrant is negative. You know that in second quadrant cos is negative. That is, cos x means f dash x is negative. Therefore, f of x is decreasing functions. In the intervals, right, that decreasing in the intervals pi by 2 to pi. Yeah. And third case, here you know that for each x belongs to the intervals 0 to pi by 2, f of x is equal to f dash x is cos x. This value is positive, and for each x belongs to the intervals pi by 2 to pi, f dash x equal to cos x is negative, and at x is equal to pi by 2, it belongs to the intervals 0 to pi, f dash x is 0. In left hand side of 0, positive means increasing, right hand side of 0 is negative means decreasing. Therefore, you can say that f of x is neither increasing nor decreasing. Neither increasing nor decreasing in the intervals 0 to pi. It's clear? And point at the point x equal to 0 is the neither increasing nor decreasing point. Left hand increase and right hand decrease. Curve is like this forms up to pi by 2 increase, after pi by 2 decreasing. At this point is the neither increasing nor decreasing point. These are direct problems. You can show that the given function is increasing and decreasing. So similarly, actually ask 2 or 3 mark questions. Find the intervals. Examples. It's clear? Find the intervals in which function f of x x square minus 4x plus 6 and decreasing, or both, either increasing or decreasing or both. Find the interval in which the functions f of x equal to x square minus 4x plus 6 is increasing functions. Second one is decreasing functions. Here you find the intervals. ಯಾವ ಇಂಟರ್ವಲ್ ಅಲ್ಲಿ ಈ ಫಂಕ್ಷನ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ, ಈ ಫಂಕ್ಷನ್ಸ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಯಾವ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಅಂತ ಕಂಡುಹಿಡಿಯಬೇಕು. Last video you know that suppose the curve is changing increase to decrease or decrease to increase, at that point is called turning point. At that point derivative is always equal to 0. Remember, at the point, this turning point, at the point x equal to a or x equal to b, this one is a turning point, increase to decrease or decrease to increase. At that point, the derivative of y with respect to x is always equal to 0. At x is equal to b is also equal to 0. These points are called turning point, critical point, stationary point. Actually, is a turning point. The curve is changes its nature. Then here find the first turning point. Here the given function is, suppose you say that y is equal to f of x, or f of x is equal to y. Y means x square minus 4x plus 6. You know that derivative is positive, increase. Derivative is negative, decrease. First verify. Here the domain of the given function is the set of all real numbers. Here remember, domain of f is equal to set of all real numbers. It means minus infinity to plus infinity, because it is a polynomial functions. It's clear? Here, therefore, derivative of y with respect to x equal to just differentiating the given functions with respect to x. Here finding dy upon dx. Derivative of x square, power functions 2x. So, minus 4 is constant. Derivative of x is 1. Derivative of 6 is 0. Therefore, 2x minus 4. It's clear? Next, if dy upon dx equal to 0, it means neither increasing and nor decreasing point. Here find the neither increase, or find the turning point. In turning point you can say that the derivative is always equal to 0. Let us assume that dy upon dx equal to 0, it implies 2x minus 4 equal to 0. It implies you get the value of x is equal to 2. 2x equal to 4. Alright, 2x is equal to 4 or x is equal to 2. This one is the turning point. At the point x equal to 2, the curve is changes its nature. Either increase to decrease or decrease to increase, or in sometimes is not only change the nature, convex to concave or concave to convex. But usually the curve is change its nature. It is called the turning point. It's clear? It means here the domain of the given function is the set of all real numbers, minus infinity to plus infinity. Only one point you get, it is the turning point. In minus infinity to plus infinity, at the point x equal to 2, the curve either changing increase to decrease or decrease to increase forms. Here verifying like this. This one is, here you know that the total domain is minus infinity to plus infinity. This interval is divided into sub-intervals. At the point 2, here the first part is minus infinity to 2 and the second part is 2 to infinity. First part is minus 2 infinity to 2, the second interval is 2 to infinity. Suppose it means only one turning point, means the curve changing only one times in the intervals minus infinity to plus infinity. Here verifying changing the curve is only one times, means either it changes increase to decrease or decrease to increase, or it is a critical point is also. Later explain the point of inflection is also. That one is minus infinity to or 2 to infinity. It's clear? Here verifying taking at least one point in belongs to the intervals minus infinity to 2. Verify derivative is positive or negative. Suppose the derivative is positive, in this intervals the curve is increase. Suppose its value is negative, derivative value is negative, then you say that in this intervals the curve decreasing motions. It is clear? Here you know that for each x belongs to the intervals, here subintervals minus infinity to 2, the dy upon dx or f dash x values. Just verify it is positive or negative. You can take in any one point, convenience points, belongs to this intervals. Verify dy upon dx is positive or negative. Here you know that you can take the values 0, belongs to this interval minus infinity to 2. Put x is equal to 0, you get dy upon dx is negative. Either in the intervals minus infinity, minus 1 is negative, minus 2 take negative, minus 3 take negative, or taking 1 is also negative. Therefore, you can simply say that this value is negative. This part is negative. It is clear? For each x belongs to the intervals minus infinity to 2, dy upon dx is negative. Here verification is just take one point belongs to the interval. Verify this value is positive or negative. Negative means it is a decreasing forms like this. Minus infinity to curve is like this forms minus infinity to 2, this value is decreasing. At the point x is equal to 2, its derivative is 0. It is neither increasing nor decreasing. Clear? Then next you can take for each x belongs to the intervals 2 to infinity. This one is not a closed interval, it is an open interval. 2 is not belongs to in this interval or this intervals. Here verify the value of dy upon dx values is, here also you can taking any values belongs to this intervals. Verify this value is positive or negative. Here you take the values greater than 2. Greater than 2 means 2 into 2 is positive. This value is greater than positive. 4 minus greater than 4 minus 4 is always positive. Suppose you can take in 3, 4, 5, 6, 7 any values, you can say that this value is positive. It's clear? In the intervals minus infinity to 2 negative, 2 to infinity positive. Therefore come to the conclusions. The given functions f of x is increasing functions, increasing in the intervals minus 2 to infinity positive values, and f of x is decreasing functions in the intervals minus infinity to 2. Here the domain is set of all real numbers. You can divide the intervals minus infinity plus infinity to minus infinity to 2 and 2 to infinity. Here verifying you get 2 to infinity is increasing and minus 2 to, it means the curve position is, this one is starting from minus infinity to 2, the curve is decreasing forms like this up to 2. This stationary point is neither increasing nor decreasing. After this 2 to infinity, this curve is like this forms. This one is decreasing up to this point. Here stagnations, next you get increasing forms. This one is the curve, shape of this curve. This is the first part, decrease. The second part, increasing. At the point x is equal to 2, you can say that this one is neither increasing nor decreasing, because the left hand side decrease, right hand side is increase. Is clear? One more problem. Find the interval in which the function is plus 7. 2x cube minus 3x square minus 36x plus 7. Here we find the intervals. This function is increasing and also decreasing intervals. Here also the given function is f of x is equal to 2x cube minus 3x square minus 36x plus 7. Here the domain is a polynomial functions, given functions f of x, remember. It is a polynomial functions, therefore the domain is set of all real numbers. Here differentiating with respect to x. What is the derivative of f of x? F dash x. 2 is constant, x cube power functions, 2 into 3 means 6 times x square. Minus 3 is constant, derivative of x square, again power functions, 2 into minus 3 means 6x. Minus 36 is constant. Derivative of x is 1. 36 into 1 means 36. Plus 7 constant, derivative is 0. Here rewrite this value. 6 is a common terms. You get x square minus x minus 6. And you get the factors. Factors this value. Split the midterms. Sum is equal to minus 1 and the product equal to minus 6. It's clear? Sum is minus 1 and the product equal to minus 6. Therefore, these factors are minus 3 and plus 2. Therefore, x minus 3 into x plus 2. That one is rough work. You write x square minus x minus 6. It means x square minus 3x plus 2x minus 6. 2 group. X is common, x minus 3. Plus 2 is common, x minus 3. X minus 3 is common into x plus 2 coefficients. Therefore, the factors are x minus 3 into x plus 2. Here also, we are finding the turning point. Turning point means the derivative is always equal to 0. Let us assume that f dash x equal to 0. It implies 6 is not equal to 0, either at least 1 equal to 0. It means x minus 3 equal to 0 or x plus 2 equal to 0. Clear? X minus 3 equal to 0 means x equal to 3. Suppose here put x equal to 3, this value is equal to 0. Or put x is equal to minus 2, this value is equal to 0. Because x minus 3 equal to 0 means x equal to 3. X plus 2 equal to 0 means x equal to minus 2. These two are the critical points. Here also the total intervals. The domain is the set of all real numbers. Domain is set of all real numbers minus infinity to plus infinity. Divide whole domain into subintervals using the turning points. Here the turning points minus 2. Minus 2 is less than 3. They are divided into 3 subintervals. The first one is minus infinity to minus 2. The second one is minus 2 to 3. The third one is 3 to infinity. Here you know that these only two turning points. The curve, it changes its nature or directions or a turn at the point x equal to minus 2 and x is equal to plus 3. ಇಲ್ಲಿ ಎರಡು ಕಡೆ ಮಾತ್ರ ಕರ್ವ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಉಳಿದಿದ್ದೆಲ್ಲ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ. These 2 points are either neither increasing nor decreasing points. Sometimes is also or critical turning point of inflection is also. It's clear? Then here verifying, you can take in any point belongs to the interval minus infinity to minus 2. Verify if dash x is positive or negative. Similarly, taking any point belongs to the interval minus 2 to 3, this f dash x is positive or negative. The similar way, you can taking any point belongs to the intervals 3 to infinity, verify f dash x is positive or negative. Positive, increase, negative, decrease. Here also, you can taking one by one for each x. This belongs to the intervals. Which intervals? Minus infinity to minus 2. Here verify f dash x values. You can taking any value belongs to the intervals. Any value means minus infinity to minus 2. Minus 3 is belongs to this interval. This 6 is positive. Suppose put the value of x is minus 3. This value is negative. This value is negative. Here you get the 6. The first quantity is positive. Right? This 6 is always positive. In x minus 3, taking minus 3 or minus 4, any values less than, its value is minus minus, again negative. And then the third one is minus 3, it is less than minus 2. Minus 2 ಗಿಂತ ಕಡಿಮೆಯನ್ನು ತಗೊಳ್ತೀವಿ, minus 2, minus 2.1, minus 2.3. Therefore, this value is also negative. Positive into negative, you get this value is positive, right? It means the curve is minus infinity to this one is increasing. It's clear. So similarly, for each x belongs to the intervals minus 2 to 3, here also verify f dash x is positive or negative. Minus 2 to 3, 0 is belongs to interval. Here also 6 positive, first factor. The second factor negative, because 0 is belongs to the 0 minus 3, it means negative. And minus 3 plus 2, this value is also here. 6 is positive, x is belongs to the intervals minus 2 to 3. 0 is belongs to intervals 0, minus 3. Put 0, this value is positive. Here you know that positive into positive, this value is negative. You say that this value is negative. It's clear. And in third case, for each x belongs to the intervals 3 to infinity, here also verify f dash x is positive or negative. Greater than 3 up to infinity, 6 is positive. Greater than 3 minus 3, its value is positive. And greater than 3, positive plus positive is also is positive. Totally this value is positive. To say that this value is positive. It means positive means minus infinity to increasing forms. Negative means minus 2 to infinity. This one is decreasing forms. It's clear? And 3 to infinity means again this one is increasing forms. The directions and difference like this or anyone. It change the natures. Increase, decrease to increase, increase to decrease, decrease to increase. Therefore, we have come to the conclusions. Therefore, f of x, the given function is increasing function in the intervals. Now, interval alli positive irado minus infinity to minus 2 or 3 to infinity. And f of x is decreasing in the intervals minus 2 to 3. All are open intervals. This one is the function is increasing and function is decreasing. At the point x equal to minus 2, you get the increasing forms. Minus infinity to 2, minus 2 increase ಆಗ್ತಾ ಇರುತ್ತೆ. Minus 2 ಇಂದ 2 ಇದರ ಸಹಾಯದಿಂದ the shape of the curve ಅನ್ನು ಹೇಳ್ಬೋದು. Here finding x-intercept and y-intercept, draw the graph easily. You can say that the graph, the portions like this forms, it is the graph. Okay, one more problems. Here verify or find the intervals. The function is increasing and the decreasing from x cube. Here find the intervals in which the functions 1 minus 12x minus 9x square minus 2x cube is increasing and decreasing. The similar type questions. Here you know that the given function is equal to, the given functions 1 minus 12x minus 9x square minus 2x cube. This one is the given functions. This function is a polynomial function, degree 3. Therefore, you can say that the domain is equal to the set of all real numbers minus infinity to infinity. Next, differentiating these functions with respect to x. 1 is constant, derivative is 0. Minus 12 is constant. What is the derivative of x? 1. Minus 9 is constant. Derivative of x square, 2x. 2 into 9, 18x. Minus 2 is constant. Derivative of x cube, 3x square. It means 6x square. We are simplifying. Suppose we are taking minus 6 is common terms. X square plus 3x plus 2. It's clear? It means its value is minus 6 into, again factorize, sum is equal to 3, the product is 2, both are positive, therefore x plus 1 into x plus 2. You know that the sum is equal to 3, 1 plus 2, product is 2. Both are positive, you know the values. Here also suppose you can taking neither increasing nor decreasing, or find the turning point. What is the turning point? The derivative is always 0. It implies minus 6 is not equal to 0. Either x plus 1 equal to 0 or x plus 2 equal to 0. X plus 1 is equal to 0 means x equal to minus 1. Put x equal to minus 1, this value is 0. Or put x equal to minus 2, this value is 0. Therefore, turning points are x equal to minus 1 and x equal to minus 2. Here minus 2 is less than minus 1. The domain is the set of all real number. This intervals minus infinity to plus infinity divided into 3 subinterval. The first one is minus infinity to minus 2. Minus 2 is less than minus 1. Next minus 2 to minus 1 and minus 1 to infinity. Is clear? Next, verify each values x belongs to the intervals minus infinity to minus 2. Verify. The first factor is minus 6. It means is negative. The second factor is x plus 1. X is belongs to the interval minus infinity to minus 2. Negative value is less than minus 2. Minus 2 ಗಿಂತ ಕಡಿಮೆ ಇದೆ ಅಂದರೆ ಇದು ನೆಗೆಟಿವ್ ಇರಲೇಬೇಕು. It is negative. Simply you can say that. And x is less than minus 2 ಗಿಂತ ಕಡಿಮೆ, again this value is also negative. Here you know that negative into negative, therefore this value is negative. Here you say that minus infinity to this value is negative. It's clear? This value is negative. Similarly for each value of x belongs to the intervals minus 2 to minus 1. F dash x, here you know that the 6 is minus 6 is negative. Minus 2 to minus 1. Minus 1.5. Suppose assume that minus 1.5 plus 1 means it is value is also negative. And minus 1.5 plus 2 is less than minus 2. Minus 1 to minus 2. It means this value is positive. Negative into positive means positive. You say that this value is positive. It is clear. Next, you can take the intervals minus 1 to infinity, f dash x. Here you know that the first factor is negative. Second factor is minus 0 is belongs to this interval. This value is positive. Next, third factor is also positive. 0 is belongs to the intervals. 0 plus 2 means 2. Or you can take in any values greater than minus 1. This value is always negative into negative means negative. You say that this value is negative. It is clear? Then write this function is increasing and decreasing. It means the curve positions minus infinity to 2. This value is negative means is a decreasing forms up to 2. It is a decreasing minus infinity. Minus 2 to 1, this value is positive means this one is increasing forms. And minus 1 to infinity, again negative means this one is decreasing. The curve like this, safe. It's clear. Therefore, this value is increasing in the intervals minus 2 to minus 1 and decreasing in the intervals minus infinity to minus 2 union minus 1 to infinity. This one is the intervals. The function is increasing and the function is decreasing. Here first find the turning points. In left hand side of turning and right hand side of turning, verify is a increasing or decreasing forms. Increase, you say that increasing in left hand side, decrease, decreasing. Sometimes is both, you get positive to positive and negative to negative. Then you say that that one is the critic and point of inflections, not a critical point. It is called the point of inflections. It not change the positions, but f dash x is equal to 0. For examples, the next one is verify the intervals. The function is find the intervals in which the functions f of x is equal to x plus 1 whole cube into x minus 3 whole cube. Is increasing functions and decreasing functions. The method is same. Here you know that multiplying these two, again you get a polynomial forms. The domain is always the set of all real numbers. The given function is x plus 1 whole cube into x minus 3 whole cube. It's clear. The domain is the set of all real numbers. We are differentiating with respect to x. What is the derivative of f of x? U into v forms x plus 1. X plus 1 whole cube. U into derivative of these functions 3 times x minus 3 whole square. First compositions functions whole raised to n, n into whole raised to n minus 1. Derivative of x minus 3. X means 1, 3 means 0. 1 into these values, same values, into second functions x minus 3 whole cube. Derivative of x plus 1 whole cube, again 3 into x plus 1 whole square, into derivative of x plus 1 is 1. Therefore, as it is. Simplify here, 3 is common terms. Against x plus 1 whole cube, x plus 1 whole square is common. X minus 3 whole square, x minus 3 whole cube. Therefore, x minus 3 whole square is common. Here, x plus 1. It's clear. The remaining terms. In this case, x plus x minus 3. Right? X plus 1 whole square, x minus 3 whole square outside, the remaining terms x minus 3. It means this value is equal to 3 times x plus 1 whole square into x minus 3 whole square into 2x minus 2. Next, if here find turning point f dash x equal to 0, it implies either 3 equal to 0 or x plus 1 whole square equal to 0 or x minus 3 whole square equal to 0 or 2x minus 2 is equal to 0. It implies 3 is not equal to 0. You know that. It is greater than 0. X plus 1 whole square equal to 0 means x plus 1 equal to 0. It means x equal to minus 1. Or x minus 3 whole square equal to 0 means x minus 3 equal to 0 or x is equal to 3. It is clear. Or 2x minus 2 equal to 0 means 2x equal to 2 or x is equal to 1. You get the 3 critical points. X equal to minus 1, x equal to plus 1 and x equal to 3. These 3 are the turning points. The curve changes its nature. ತನ್ನ ನೇಚರ್ ಅನ್ನು ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮಾತ್ರ, ಅದರ್ವೈಸ್ ದ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ ಕರ್ವ್ ಎಲ್ಲೆಲ್ಲ ಚೇಂಜ್ ಆಗಿರುತ್ತೆ ಅದೆಲ್ಲ ಟರ್ನಿಂಗ್ ಪಾಯಿಂಟ್ಸ್ ಆಗಿರುತ್ತೆ. ದ ಡೆರಿವೇಟಿವ್ ಇಸ್ ಆಲ್ವೇಸ್ 0, ರಿಮೆಂಬರ್ಸ್. Otherwise it is increase to this value, decrease or increase, decrease, increase, decrease like this. Other ಡೆರಿವೇಟಿವ್ 0 ಬಂದಿದೆ ಅಂದರೆ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕರ್ವ್ ತನ್ನ ಡೈರೆಕ್ಷನ್ ಅನ್ನ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ ಅಂತ. ಇಟ್ಸ್ ಕ್ಲಿಯರ್. ಹಿಯರ್ ಆಲ್ಸೋ ದ ಡೊಮೇನ್ ಈಸ್ ದ ಸೆಟ್ ಆಫ್ ಆಲ್ ರಿಯಲ್ ನಂಬರ್ಸ್ minus infinity to plus infinity. This interval is divided into 4 sub interval. One is, you get this means minus 1 is less than 1 and 3, the next 1 and 3. Minus infinity to minus 1, minus 1 to plus 1 and 1 to 3, 3 to infinity. Just remember. Next, verify the first case, or you can take the table list also in this form. Here you know that this one is the intervals, this one is f dash x. This one is the values, the intervals. The first one is minus infinity to minus 1. Second one is minus 1 to 1. Third one is 1 to 3. The next one is 3 to infinity. It is clear. Here verify. Minus infinity to minus 1, less than minus 1. You can taking any values. Verify this value is positive or negative. Here remember 3 is always positive. Square, either x is positive or negative, this value is positive, this value is positive. Only verify. Or here you can taking 2 is outside, x minus 1, 2 is positive. Only verify x minus 1 is positive or negative. It depends on this values. It means this value is equal to f dash x is equal to, here you know that f dash x is equal to 2 into 3 means 6 into x plus 1 whole square into x minus 3 whole square into x minus 1. It is clear? This positive, positive, positive. Only verify x minus 1 is positive or negative. ಇಲ್ಲಿ ಹೇಗೆ ಬಂತು x minus 1 2 common terms ತಗೊಂಡು 2 into 3 ಮಾಡಿದ್ರೆ 6 ಬರುತ್ತೆ. That value is x minus 1. We are taking any values minus infinity to minus 1. Less than minus 1 take. This value is positive or negative. Less than minus 1 this value is negative. Right? This value is negative. Next. Minus 1 to 1, 0 is belongs to the intervals. This value is also negative. All these are positive. Negative into positive means negative. Greater than 1, you can take in 1 in the HG. Greater than 1, 1, 2, 3, this value is positive. Next, greater than 3, this value is also positive. Here you know that. Not usual way, positive, negative, not like that. This value is negative, negative, positive, positive. You know that minus 1 is the turning point, but that point is not a neither point of increasing point nor decreasing. It is either increase or decreasing. Therefore, you can say that this value is negative, this value is positive, this value is positive. It means the curve is changes its nature positive to positive, concave up and concave down. Study in the maxima and minima class. Here also negative to negative. The turning points, you say that either increase to decrease or decrease to increase, these points are turning points. Similarly, concave up and concave down, like this forms, concave to convex or convex to concave forms. Change the nature. ತನ್ನ ಡೈರೆಕ್ಷನ್ ಅನ್ನು ಸಡನ್ ಆಗಿ ಚೇಂಜ್ ಮಾಡುವಂತ ಪಾಯಿಂಟ್ ಇದು. neither increase nor increasing point alla, either increase and decreasing, but at this point the curve is changes its nature. It is a turning point clearly, and this type of point is called point of inflections. Here this point is point of inflections, this point is point of inflections. The curve change the natures convex to concave, concave down and concave up forms. Therefore you can say that f of, here you just write it is a increasing functions or decreasing. The intervals, the function is increasing and the function is decreasing. Here you said that f of x is increasing functions. In the intervals, the total 1 to infinity. Here 3 is also point of increase because left hand side positive, the right hand side is also positive. Suppose is positive and negative, one is not a point of inflections, only turning points. Remember, the left hand side is negative, right hand side is positive. Therefore, this point is neither point of increasing or not decreasing. And f of x is decreasing functions. In the intervals minus infinity to 1. Here minus 1 is also point of decreasing. ಇದು ನೆಗೆಟಿವ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಹೇಗೆ ಬರುತ್ತೆ? ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಮತ್ತು ಪುನಃ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಕರ್ವ್ ತನ್ನ ಡೈರೆಕ್ಷನ್ ಅನ್ನು ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಇದು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಹೀಗೆ ಬರುತ್ತೆ ಅಂದರೆ ಕರ್ವ್ ಡೈರೆಕ್ಷನ್ ಅನ್ನು ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಕಾನ್ವೆಕ್ಸ್ ಇದ್ದು ಕಾನ್ಕೇವ್ ಫಾರ್ಮ್ನಲ್ಲಿ ಬರುತ್ತೆ. ಎಲ್ಲಿ ದಿಸ್ ಪಾಯಿಂಟ್ ಜಸ್ಟ್ ಫಾರ್ ಯರ್ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿಯಿಂದ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ ಹೇಗೆ. ಆಮೇಲೆ ಮೈನಸ್ 1 ಬಂದಮೇಲೆ ಅಗೇನ್ ಡಿಕ್ರೀಸು ತನ್ನ ಡೈರೆಕ್ಷನ್ಸ್ ಇದೇ ಡೈರೆಕ್ಷನ್ಸಲ್ಲಿ ಹೋಗೋದಿಲ್ಲ, ಡೈರೆಕ್ಷನನ್ನು ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಅಗೇನ್ಸ್ ಪುನಃ ಇದು 3 ತನಕ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಮತ್ತು ಪುನಃ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಲೈಕ್ ದಿಸ್ ಫಾರ್ಮ್ಸ್. ಇಟ್ ಇಸ್ ಕ್ಲಿಯರ್ ಅಟ್ ದ ಪಾಯಿಂಟ್ x equal to 3. ಕರ್ವ್ ಲೈಕ್ ದಿಸ್ ಆಫ್ ಸೇಪ್ ಹೀಗೆ ಅಂತ ಅಥವಾ ಕಾನ್ಕೇವ್ ಡೌನ್ ಆ್ಯಂಡ್ ಕಾನ್ಕೇವ್ ಅಪ್. ನೆಕ್ಸ್ಟ್ ಮ್ಯಾಕ್ಸಿಮಾ ಮಿನಿಮಾದಲ್ಲಿ ಬರುತ್ತೆ, ಅಲ್ಲಿ ಕ್ಲಿಯರ್ ಆಗಿ ಹೇಳ್ತೀವಿ. ಇಲ್ಲಿ ವೆರಿಫೈಯಿಂಗ್ just or find the intervals, the function is increasing and the function is decreasing forms. This figure is not necessary, just for understanding the properties. The next questions, one more problems. Find the intervals in which the function is increasing and the function is decreasing. Suppose sin x plus cos x. Here given the domain is equal to 0 to 2 pi. The domain is equal to 0 to 2 pi. Here the given functions, the method is same. The given function is sin x plus cos x defined in the interval 0 to 2 pi. In one revolution, now verify marta idvi. What is the domain of the given functions? Already is given. The closed intervals 0 to 2 pi. It's clear. Here differentiating with respect to x. What is the derivatives? Sin x means cos x means minus sin x. It's clear. It implies, or you can say that if f dash x equal to 0, first find the turning point. It implies cos x minus sin x equal to 0, or tan x is equal to 1. It's clear? Sin x is equal to cos x. Sin x equal to cos x means tan x is equal to 1. It means this value is tan of pi by 4, or in third quadrant you can say that tan of 3 pi by 4. Pi plus pi by 4, 5 pi by 4. First quadrant positive, third quadrant pi plus 5 by 4, 5 pi by 4. It's clear. Therefore, the turning points are x equal to 5 by 4 and x is equal to 5 pi by 4. These two values belongs to the intervals 0 to 2 pi. These are the turning points. Here also verify the given function is increasing and decreasing functions. It's clear? Here you know that this one is minus 0 to 2 pi. Here sub-intervals pi by 4 and this one is 5 pi by 4. Here verify the first case. For each x belongs to the intervals 0 to pi by 4. Verify f dash x is positive or negative. You can taking any values between 0 to pi by 4. This means f dash x means cos x. Cos of any values lies between 0 to pi by 4. You know the curve of the cos x like this, sin x like this. In pi by 4, these two curves are intersecting. You get the same values 1 by root 2. In cos x is greater than, in 0 to pi by 4, cos x is greater than sin x. Gottide namage trigonometric results. In 0 to pi by 4, cos x is greater than sin x. Therefore, in 0 to pi by 4, cos x greater than sin x. So, cos x value sin x ginta doddu andre this value is positive. It's clear? Here you know that 0 to pi by 4, cos x is greater than sin x. Therefore, f dash x is positive. It's clear? Next, second intervals. For each x belongs to the intervals 5 by 4 to 5 pi by 4. The curve like this, one cyclic hege ಬರಿತೀವಿ ಅಲ್ವಾ cos x ಹೀಗೆ ಬರುತ್ತೆ like this. ಇದು ಹೇಗೆ ಬರುತ್ತೆ pi by 2 think that this one is pi by 2 ಇದ್ದಾಗ 1 ಹೀಗೆ 3 like this. ಹೀಗೆ ಬರುತ್ತೆ. It is clear. Sin x ಮತ್ತು cos x ಇದು ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗೋದು ಅಂತ ಪಾಯಿಂಟು 3 pi by 4. 3 pi by 4 ಅಲ್ಲಿ sin x value is greater than cos x. So, it means sin x is greater than cos x. Therefore, you can say that f dash x is sin x greater than cos x means this value is negative. This value is negative. You write directly, take a tables, intervals and f dash x values. Just verify it is positive or negative. The next one is the third intervals. For each x belongs to the intervals 5 pi by 4 to 2 pi. this value is sin x, so this value is cos x. So here you know that in 3 pi by 4 to 2 pi, cos x is greater than sin x. So clear? It means cos x is greater than sin x. Therefore, you can say that f dash x is positive because cos x minus sin x positive. Therefore, come to the conclusions. F of x is increasing functions in the intervals. Positive means 0 to pi by 4 union or 5 pi by 4 to 2 pi, and decreasing functions in the intervals pi by 4 to 5 pi by 4. This one is the function is increasing and decreasing. And last problems. Suppose f of x is equal to, here where find the intervals in which the functions f of x is equal to x log of 1 plus x minus 2x divided by x plus 2, and x is greater than minus 1 is increasing and decreasing. The solutions. Here the given functions f of x is equal to log of 1 plus x minus 2x divided by 2 plus x, given that x is greater than minus 1. Therefore, the domain of the given function is minus 1 to infinity, greater than minus 1, positive values, because the domain of the log function is always positive real numbers. Just remember, ಇದು positive ಬರಬೇಕು ಅಂದ್ರೆ x is greater than minus 1 ಆಗಿರಬೇಕು, and this value is not equal to 0. The next one, here differentiating the given functions with respect to x. Log with respect to 1 plus x, 1 divided by 1 plus x. Derivative of 1 plus x is 1. Minus 2 is constant 2. U by v forms. Denominator 2 plus x. So the derivative of x means 1. Minus, so numerator means x. So the derivative of 2 plus x, 2 constant 2. X is 1. Divided by denominator whole square. 2 plus x whole square. Here plus x minus x cancel. This value is 1 divided by 1 plus x minus 2 into 2, 4 divided by 2 plus x whole square. Next, taking the LCM. LCM is 1 plus x into 2 plus x whole square. 1 into 2 plus x whole square. 2 square is 4. It's clear? Alright, one steps. 2 plus x whole square minus 4 into 1 plus x. Simplify, you get its value is equal to denominator 1 plus x into 2 plus x whole square. Here 2 plus x whole square, 4 plus 4x plus x square minus 4 minus 4x plus 4 minus 4 plus 4x minus 4x cancel, x square divided by 1 plus x into 2 plus x whole square. Here also, what is the domain of the given functions? Take its value is equal to 0. If f dash x equal to 0, you first find the neither increasing nor decreasing. F dash x equal to 0 means denominator is not equal to 0, only numerator is 0. Numerator 0 means x square is equal to 0. It implies x is equal to 0. Only one point. Therefore, this one is the domain is minus 1 to here infinity. Here 0 is belongs to these intervals. Only two subintervals, minus 1 to 0, 0 to infinity. It is clear. Next, you verify for each x belongs to the intervals minus 1 to 0. What is f dash x? Here you know that f dash x equal to x square. X square is always positive. Divided by 1 plus x into 2 plus x whole square. It is clear. Numerator is always positive. Denominator one term is positive. Here only verifying 1 plus x is positive or negative. X is less than 0, greater than minus 1, less than 0 and greater than minus 1 means this value is 0 ginta chikkadu, minus 1 is the negative, greater than minus 1 plus minus 1, this value is also positive. You can say that this value is positive. It's clear. And for each x belongs to the interval 0 to infinity, f dash x, numerator positive, denominator one terms positive, and other term is 1 plus x, x is always positive, adding 1, this value is also positive. You can say that this value is also positive. Therefore, you said that f of x is strictly increasing functions. In the intervals minus 1 to infinity. In whole domain, the function it is a monotonically increasing. It means this point 0 is the actually point of inflections. At the point 0, suppose like this, minus 1 to 0, the curve is increasing, either convex curve of forms, then it suddenly change its nature like this forms. It's clear. This one is the functions like this, but totally is increasing functions. It is monotonically increase, but ತನ್ನ ಡೈರೆಕ್ಷನ್ ಅನ್ನು ಝೀರೋದಲ್ಲಿ ಅದು ಚೇಂಜ್ ಮಾಡುತ್ತೆ ಅಂತ. These are the here finding the point of intervals. The function is increasing and the function is decreasing. Next ವಿಡಿಯೋದಲ್ಲಿ ನಾವು the geometrical meaning of dy upon dx, equation of tangent, equation of normal, slope of tangent, slope of normal ಅನ್ನು ತಿಳ್ಕೊಳ್ಳೋಣ. Thank you.